Hey guys! Today we're going to be talking about ratios and proportions. And can be found on page 142. So open up your books to page 142 and we'll get started. There's lots of vocabulary today, but before we hit the vocabulary, we're going to just do a little bit of review. We're going to talk about cross products. So if we have A over B equals C over D, then you can multiply across like this, and they equal one another. So A times D is equal to B times C. And these guys are called cross products. Okay? They're across and they're multiplied. All right, so let's just look at this. If we have 2/3 equals 8/12, 2 times 12 is going to equal 8 times 3. Let's see if that's true. 2 times 12 is 24, and 8 times 3 is 24. Okay, perfect. Great. All right. Okay, lots of information to cover today. First, vocabulary. First vocabulary word is ratio. A ratio is a comparison of two numbers. A little shorthand there, two numbers by division. Okay, great. That's ratio. Next vocab is the word rate. And rate is a ratio of A to B, where A and B represent quantities measured in different units. Okay, so something like miles per hour is a rate, okay? Okay, next vocabulary word is unit analysis. All right. Unit analysis is the process of selecting conversion factors to produce the appropriate units. Okay, awesome. Unit analysis, the process of selecting conversion factors to produce the appropriate units. Okay, and last vocabulary word is proportion. And a proportion is an equation that states that the ratios are equal. All right, so all these words are going to be in our lesson today, and you're going to have to know how to use them and know what they mean. So there they are. Okay, so if we have the proportion A over B equals C over D, and I want to define the extremes of the proportion, okay? The extremes are going to be A and D, okay? These two values right here. And then if I want to ask about the means of the proportion, I bet you cannot guess that the means are going to be C and B, okay? So the extremes are the ones on the outside furthest away, and the means are the ones in the middle if you're reading like this. Okay? All right. And then in the proportion here, the cross products, we talked about this a little at the beginning, are AD and CB. Okay? So AD equals CB. You just multiply across the equal sign there. All right? Okay. Okay, let's talk about unit rates. This is going to be a unit rate problem. And it says, a brand of grapefruit juice cost $1.56 for 48 ounces. Okay, and it says find the unit rate. Okay, and as I like to always point out, this right here is real world math. I used this just the other day. I was buying Gatorade at Sam's and I was trying to figure out which bottles were cheaper, the 20-ounce bottles or the 12-ounce bottles. And so I did this exact math. I used my calculator, but this is real world math that you will use many, 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 many times in your life, okay? So to find the unit rate for the grapefruit juice that costs $1.56 for 48 ounces, you're going to divide the total by the number of ounces, okay? So it's cost over ounces, all right? So when we divide 1.56 divided by 48, we're gonna get 0.0325 cents per ounce, okay? So the unit rate is this right here, 0.0325 cents per ounce. And we said earlier that a unit rate has a denominator of 1, okay? So this is this many cents per 1 ounce, all right? Okay. Okay, next we're going to talk about applying proportions. And this is a similar problem to what's in your book, but it's maybe different numbers, okay? In 2000, Lance Armstrong completed the 3,630 kilometer Tour de France in 92.5 hours. Traveling at his average speed, how long would it take Lance Armstrong to ride 295 kilometers? Okay, so we're going to say that T is the time needed to ride 295 kilometers, okay? And then we have his average speed, which equals his 295 kilometer trip, okay? All right, so we have 3,630, which I said was the complete amount of kilometers, that he rode, divided by the time it took him, which was 92.5 hours, okay? And so that's gonna equal the ratio of 295 kilometers to T, the time needed to ride there, okay? So what are we gonna do here? We're gonna cross multiply, okay? We're gonna use the cross products. It's gonna be 3,630 T equals 295 times 92.5. Let me see if I can find here. Oh, I just did it all in my calculator. I don't have the number. So you're gonna multiply this out and then divide by 3630. And T is gonna equal 7.5, okay? So his average speed would be 7.5 hours for 295 kilometers, okay? Okay, so we're gonna do a problem that's using applied proportions, okay? I'm gonna read you the problem and then I'm gonna write the pertinent information on the board, okay? In the year 2000, Lance Armstrong completed the 3,630 kilometer Tour de France. And it took him 92.5 hours to do that. Traveling at his average speed, the question is, how long would it take him to ride only 295 kilometers, okay? So we have 3,630 kilometers over 92.5 hours, and we want to know how many hours it would take him to go 295 kilometers, okay? So we're going to let t equal the time it would take him to go 295 kilometers. Okay, so this is basically a proportion, so two ratios that are equal to each other, okay? And we're going to solve for t. So we're going to say 3,630 kilometers over 92.5 hours equals, on this side, 295 kilometers equals t, which will also be in hours, okay? So when your proportions are equal to each other, your ratios are equal to each other, you have to have the same units, kilometers per hour, okay? So to solve this proportion, all we're going to do is cross multiply, okay? Using our cross products, we're going to get 3,630 t equals 295 times 92.5. I forgot to multiply this out, so it's just 3,630 divided by 3,630 over here. So t is going to equal about 7.5 hours when you multiply this together and divide by 3,630. Okay, so the answer to how long would it take him to go 295 kilometers is 7.5 hours. Okay. All right, so we're gonna talk about a problem where we're converting rates. And when you are converting from one unit to another, as in converting hours to minutes or minutes to hours, you have to decide which conversion factor will produce the appropriate unit. We talked about this earlier. It's called unit analysis. Okay, so just let's look at this. 60 minutes is 1 hour. And you could say 60 minutes over 1 hour is how many minutes? It's 60 minutes. And that equals 1, okay? So using it is totally fine because it's just 1, okay? And it's the same, you can also say it like this, 1 hour is 60 minutes, and that also equals 1. Okay, for the same reason. Here, you can either have 1 hour on the bottom or 60 minutes on the top, and it still equals 1. Okay, this will become more clear in just a minute when we talk about our problem. Okay, so the fastest recorded speed for an eastern gray kangaroo is 40 miles per hour, okay? What is the kangaroo's speed in feet per second, okay? So miles per hour, and we want to get down to feet per second. So I'm going to show you how to do that, okay? So this is going to be, you're going to be multiplying, all right? So because we have miles here, we want to put miles on the bottom as well. And we're just going to use 1 mile. And we want feet. So we know how many feet are in a mile. We learned that probably back in 3rd grade, maybe 4th grade. There are 5,280 feet per mile. And it's super important to have all your labels on here because you're gonna get really lost if you don't, okay? All right, so we have miles and we have feet. Okay, but we're still looking for seconds over here. So we have an hour here. So I'm gonna put 1 hour is 60 minutes, okay? And we still want seconds. So we have minutes here. So we're gonna put 1 minute over 60 seconds, all right? Okay, so then what happens is all of these that are, when you have a mile in the numerator and 1 in the denominator, they cancel out, okay? So the miles are gonna cancel, the hours are gonna cancel, the minutes are gonna cancel, and all you have left is seconds and feet, which is exactly what we're looking for, okay? Feet per second. All right, and so now you just multiply across the top and across the bottom, so it becomes 40 times 5,280 times 1, we don't need to write that out, over, we had a 1 there, 1 times 60 times 60, okay, times 60 times 60, and in the end, that becomes 558.7, and it's feet per second, okay? And we're gonna do another one just like it. So a cheetah ran 300 feet in 2.92 seconds, okay? And it says, what was the cheetah's average speed in miles per hour, okay? So we're gonna look for the conversion factors, do the unit analysis here to get to miles per hour, okay? So we're looking for miles. So we said earlier that 1 mile was how many feet? 5,280, 80 feet, okay? Remember, this is multiplication. And then there's seconds are on the bottom, so we're gonna wanna put that on top. 60 seconds per 1 minute, okay? And then we want hours, so 60 minutes per 1 hour, okay? And so now we're gonna go through and we're gonna cancel all the ones that cancel. So feet cancel, seconds cancel, minutes cancel, and that's gonna leave us with miles per hour, which is what we're looking for, okay? So then remember, you're just multiplying across. This is not an equal sign, that's a multiplication. Okay, so it's 300 times 1 times 60 times 60 over 2.92 times 5,280 times 1 times 1, and that's gonna leave us with 70 miles per hour, okay? Okay, so just a couple of quick things. A problem that says, the Main Street florist sells 2 dozen roses for $24.60. And the U florist sells 6 roses for $7.50. 6 for 750, okay? It says find the unit rate for each and which florist has the lower cost per rose. Okay, so we know that 2 dozen roses is actually 24. So we're gonna do 24.60, the total cost, divided by 24. So it's cost divided by number, and that's gonna give us $1.03 each, okay? That's for the Main Street florist, okay? So then to figure out how much the U florist cost, we're gonna do 750, the cost over the number per 6 roses, and that's gonna come out to $1.25. So if you're wanting to buy roses, I recommend the Main Street florist because they're gonna be cheaper per rose, okay? Again, this is a unit rate problem, and we were just figuring out how much something cost per one of them, okay? All right. Next, we're going to do a multi-step proportion, and let's say we have x plus 3 over 4 equals x minus 4 over 6, okay? And all we're going to do here is use our cross products, okay? So we're going to multiply across and set them equal to each other. So it's going to be 4 times the quantity x minus 4 equals 6 times the quantity x plus 3. And next we have to use the distributive property. So it's going to be 4x minus 16 equals 6x plus 18. And these are the equations we were doing the other day. I'm going to isolate the x. So first I'm going to subtract 4x from both sides. That's going to leave me with negative 16 equals 2x plus 18. I'm going to subtract 18 from both sides. I'm going to get 2x equals negative 34. And then I'm going to solve for x. I'm going to come up here, negative 34 equals 2x. Divide both sides by 2. X equals negative 17. Okay? All right. Where's Birdie? Okay. One more type of problem, and then we'll be done. Okay, it says, suppose you walk 2 miles in 35 minutes, okay? And the question says, find your average walking speed and write a rule to describe the distance d that you walk as a function of the time you walk, okay? All right, so if we want to find our average walking speed, it's going to be distance over time. So that would be 2 miles over 35 minutes. And we're going to use, excuse me, that's not an equal sign. It's a multiplication. The conversion factor that we talked about just a few minutes ago, and it's going to be 60 minutes per 1 hour, because we want to know our average walking speed. So that's going to be miles per hour, okay? So our minutes here are going to cancel out, and we're going to multiply this, and we're going to get 120 miles over 35 per hour, and then you're just gonna divide that and you're gonna get 3.4 miles per hour, okay? And the other question that it said is write a rule to describe the distance d that you walk as a function of the time you walk. So that would be d equals 3.4 times t, okay? All right, great. I'm gonna give y'all your assignment. It'll be written out, and you're gonna do some problems from the book. And if you have any trouble, I'll be back for the next lesson.